All right, I'm back. I wanted to talk to you about lesson 23. It's the last session, it's refine. So this is where we're going to use everything that we've learned to do all of these problems. You can break this down into chunks so it's easier for you because this is a lot of review. But I am going to go over the first bit with you. So on page 517, it says up here, Matt says that 3/3 is equivalent to 1. Elisa says 8/8 is equivalent to 1. Who's correct? So I'll give you a minute to think about that. Well, they're both correct. Because if you have 8 pieces and 8 of those pieces are used, 1, 2, 3, 4, 5, 6, 7, 8, that is a whole. Same with 3/3. We break it down and all 3 of those thirds are being used, that is in fact 1 whole. So they are both correct. If your denominator and your numerator match, that is equivalent to 1 whole. 4/4, 5/5, 6/6, 3/3, 8/8. So they're both correct, okay? But I do want you to show your work. You should be doing that on all of your problems. So if a parent or I look at it, we can tell exactly what you're thinking. Number 2 says write 2 fractions that are equivalent to 5. So this is where you are going to show 2 models, or you could use 1 model, but show it in 2 different ways of fractions that are equivalent to 5. So what I would do is I can draw 5 cookies. 1, 2, 3, 4, 5. Now, to make it easy for you guys, I'm going to break those into halves. So I'm going to do 2 is my numerator. I'm sorry, 2 is my denominator. The denominator goes down. That is the total pieces, parts of the whole. Okay, so here I have, if I have 1, 2, that is 2. Add 2 more. I'm counting by 2s. Oops, and I made a mistake. Did you see that? This is not 2 halves. This is now 4 halves. 2, 4, 6, 8, 10. So one of the ways that I can write 5 in a fraction is 10 halves. If I do 2 times 5, I get 10. 10 divided by 5, I get 2. So multiplication and division both work into that. Now it's asking for 2 fractions, so I have to do another one. Here I did 1 model of cookies, so I'm going to do Miss Williams' favorite, which is the number line. So we'll always start at 0 and 5. So now I need 4 lines because I have 1, 2, 3, and 4. It's not perfect, it doesn't have to be. Now I'm going to break these in. I did halves just to make it easier. Again, I'm going to break them into thirds. So this is 1 whole, 2 whole, 3 whole, 4 wholes, 5 wholes. Now I'm going to break each whole into thirds. When you are breaking them into thirds, you're going to need 1, 2 lines for each chunk. So 1, 2, 1, 2, 1, 2, 1, 2. Now I can count my pieces, 1, 2, 3. I have 3 pieces. My denominator is going to be 3. 3, 3. Now this is the fun part. This is like you're hopping on number line because you are. But I like to think of it as hot lava. So we're going to hop all the way down to 5 wholes. We're going to start out with 0 thirds. 1/3, 2/3, 3/3, 4/3, 5, this would be 6/3, 7, 8, 9/3. 3 times 3 is 9. 9 divided by 3 is 3. 3 times 2 is 6. 6 divided by 3 is 2. Pretty cool. 9. Keep going. 10, 11, 12 thirds. This is 13, 14. 15 thirds. So I also know that I can write 5 as a fraction as 15 thirds. 3 times 5 is 15. 15 divided by 5 is 3. 15 divided by 3 is 5. Those are fact families. So I would write for my problem, my answer would be 10 halves and 15 thirds. But you need to show your work. You can't just use what I'm doing. You can use what I'm doing, but you need to write the whole thing out so you understand it. Make those lines in your brain. All right, number 3. Kaya ate 3/6 of a banana. Zoe ate an equivalent amount. Equivalent means equal, right there. Which fraction shows how much of a banana Zoe ate? So we need to find out what is equivalent to 3/6. So I drew a model of 6, and it's, again, not perfect, but if it were, all these pieces would be equal. But I have 1, 2, 3, 4, 5, 6. And so my denominator is 6 because there's 6 parts. She ate 3 of those. 1, 2, and 3. So like we talked about in class, you can do the process of elimination. So with all of these, you can go ahead and looking for, if you notice, 3/6 looks very similar to 1/2. But I want to be certain. I don't want to just guess. So I'm going to do the same thing for all of these. Thirds. She ate 1/3. Is that the same? No. How about 2/3? 1, 2. Nope, not that. 5/8. Okay, so I'm going to break it down into 8s. 1, 2, 3, 4. She ate all that. And she ate all that. Does that work? No. How about this? Yes. So now I know that 3/6 is equivalent to 1/2. If you take 6 and divide it by 3, you get 2. If you take 2 and divide it by 1, you get 2. So equivalent fractions will always work out that way. All right, now number 4. This is at the top of page 519, and it says, which model shows a fraction equivalent to 2/6? So this is where, if you can tell, my models are not drawn to scale. They're not all the same size, but this is where some of this math is going to really come in handy to help you out. So first, 2/6, I drew it up here. That's the first thing that I would always recommend, is to draw it. So here's 2/6. I have a bar. I broke it into 6 pieces. 1, 2, 3, 4, 5, 6. I colored in 2. That is 2/6. I can look at these in your book, and you can automatically tell which ones are not the same. So A is bigger. If it was 1/2, this is 1/2, then this other one would be filled in, but it's not. B. This is 1, 2, 3, 4. This is 1 out of the 4 is colored in. That one is also not correct. 1, 2, 3, 4, 5, 6, 7, 8. This one is 2 8s. And this one is 1, 2, 3, 1/3. So down here, what I did to show you guys that it's equivalent, if sometimes your models aren't working out correctly, I'm looking for what is equivalent to 2/6. So you take the denominator and divide it by the numerator, and you get 3. So 6 divided by 2 is 3. Here, if I take 3 and divide it by 1, I'm going to get 3. If I were to stack these on top of each other, again, this is where your book of knowledge with your rainbow strips is really going to come in handy. If you lost that or can't find that, you can always make your own strips as long as it's okay with your parents. But here you have 1 and 2, and you can tell that 1/3 is equivalent to 2/6. So it's not A, it's not B, it's not C, it is in fact D, 1/3. Number 5, it says, draw a model to find a fraction equivalent to 1/4. Show your work. So this is where we're looking for a fraction that is equal to. So on one side, either the top or the bottom, you're going to do a 1/4, and then on the other side, you're going to pick one that's going to find out what is equivalent to it. If it is an even number, which our even numbers are 0, 2, 4, 6, and 8. If it is even Steven, like these numbers, which 4 is, then your fraction has to be one of these for it to be equivalent. So I'm going to break this into fourths, which means I'm going to do 1, 2, 3 lines. So here I go, 1, 2, 3 lines. And now I know that this is my denominator because I have 4 pieces. So this is 1/4, 2/4, 3/4, and this of course would be 4/4 is equivalent to 1 whole. So now I'm going to pick one of these numbers and I'm going to choose 8 because I know I can easily fit that in here. So 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. Now I have 8 pieces and I'm going to write my denominator, which for all of these is going to be 8. And then I'm going to jump on the number line. So it would be 8 eighths. This one would be 0 eighths. 1, 2, 3, 4, 5, 6, 7, and 8. So now I can tell it said to find a fraction equivalent to 1/4. How I did it is I can now look and see what is right in line, like a column like the White House. This is vertically. And your answer is 2 eighths. So I filled in all of the rest just because it's good practice, and I would like you to do that as well. So if you need to at any point, you can hit pause and write down what I did so you can understand it better for your brain. I'm going to go ahead and erase now, so if you need to pause to write all this down, please do. Keep that up there so you guys can always remember. All right, number 6, it says, look at point P on the number line. So you're going to use that to answer the questions in the table below. Does the point on each number line below represent a fraction equivalent to the fraction shown by P? So that is where you're going to have to mark that on the number line and relate right in those fractions. So the first thing I'm going to do is I'm going to write down the model, and then I'm going to try to match it with those because I'm trying to show you guys what it is. 0, and it goes all the way to 1. And I'm going to count the dots, or the lines, the pieces, excuse me. 1, 2, 3, 4, 5, 6, 7, 8. So this is eighths. So I'm going to draw 7 lines. 1, 2, 3, 4, 5, 6. Okay. 7 lines. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I'm going to draw 7 lines. Okay, 1, 2, 3, 4, 5, 6, and then I'm drawing here 7. 1, 2, 3, 4, 5, 6, 7. It's a little bit off, but it works. 8, 8. There's 8 pieces, so your denominator is 8. P is 1, 2, back. So what you need to do is fill in your number line, all of your numerators and denominators. Okay, this one would be 8 eighths. This one is 0 eighths. All right, now that I've solved that, or started with that, I can now answer the other questions. So you need to know what you're working with first if you're going to compare it to other problems. So then the question says, I'm going to read it again, so you can feel free to read them all 3 times. Does the point on each number line below represent a fraction equivalent to the fraction shown by point P? So then I'm going to look at the first one, and I'm going to count how many pieces there are. 1, 2, 3, 4. So that would mean there's going to be 3 lines. So I'm going to actually use a different color. You guys can really see this. So here it is. 1, 2, 3, and yep, just double checking my work. So here, the dot is right here. and it's fourths. So here's 1/4, 2/4, 3/4, 4/4 of the whole. So is it equivalent to 6/8? Yes, it is. So for the first one, you would write yes. Okay, and then the next one, let's see, this one is thirds. And if you notice, do you notice that the blue dot is moving? So if one is yes, and these are over to the left, don't you think that they would be no? I do. But let's verify. All right, so I have 1, 2, 3 pieces, which is going to be harder to do. So I'll do it down here. 0 and 1, and we have 2 lines. Okay, and then the dot is here. So that one would be a no. And this is 1/3, 2/3, 3/3. And the next one is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 pieces. So then you're going to take this 1, 2, 3, 4, 5, 6, and the dot remains the same. So that one is also no. They're not equivalent. If you have your rainbow strips again, that would be a really great way. You can just line them all up and see. On the back, number 7, does the point on each number line represent one whole? Ooh, this is fun. All right, I'm gonna erase this. Again, if you need to write it down, feel free to pause at any time. So we are looking for if the point on the number line represents one whole. So you don't even really need to use the number line for this. If I were you, I would look at the fractions and just make that decision on your own. If you need to jump on the number line, then that is fine. But the first one in the table, the first row, like a rowboat, is 1 of 1. And I know that that is one whole because earlier we mentioned if the numerator and the denominator match, then that means it is one whole. So that is correct. That represents one whole. Yes. There's one piece, one whole, and there's one of them. So that's one whole. 4 over 1. Well, this one represents, if you remember from our peppers, I have one whole, but I have 4 of them. So this was I have 4 wholes. So this one would be no. Then I jump to the third row, and it is 1. 1 represents one whole. So that one is yes. Last one is 4/4. I'm just trying to trick you, but again, the numerator and the denominator match. So if I have a whole orange and I eat all 4, these are the parts. These are the total parts, and these are the parts that you're eating. I eat the whole. So that one is yes as well. All right, use the number line, number 8 on page 520. Use the number line to find a fraction equivalent to 3. Show your work. Okay, I have to draw mine. So 0 and 3. And then I have to draw 3. So there's 2 lines, 1 and 2. This is 1 whole, this is 2 wholes. So now this is where, again, you can choose your own fractions and how you want to break it down. So I'll do fifths. So I need 1, 2, 3, 4 lines. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And my denominator is going to be 5. I know that 1 is equal to 5 fifths. 5 plus 5 is 10, so that's why I just filled in the 10. Um, 5 times 3 is 15, so I can just fill this in, and then I just jump on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you want, you can do what I did, where the whole numbers, I just knew 5 plus 5 is 10, 5 plus 5 is, 5 plus 5 plus 5, or 5 times 3 is 15. And then you can go back and fill in like I did and check your math, see if you got it right. So I chose fifths. So now I know that 3 is equivalent to 15 fifths. 5 times 3 is 15. 15 divided by 3 is 5. 15 divided by 5 is 3. It's a fact family. Pretty cool. Number 9, it says write 2 fractions equivalent to 4 using the denominators 1 and 3. Use a number line to show how you found your answers. So here you don't have a choice in the model. You need to use a number line, which I think is really good because a lot of you, I think, are intimidated or fearful of the number line, and it's really your friend. So I'm going to equivalent to 4. So that means you're going to do 4 holes. So you're going to start 0. You're going to go all the way to 4. If you're doing 4, then you need to draw 1, 2, 3 lines. It's always one less. 1, 2, 3. 1, 2. Move those up actually. 1, 2, and 3. So then it gives you just instructions. It says using denominators of 1 and 3. So that means 1 and 3. So if I'm using 1, that means I'm not breaking it up at all like the peppers. I'm going to keep them whole. So use a number line to show. So write 2 fractions. So I'm going to make my whole up here. So this would be my 1s. And this is where you just jump. So 1, 2, 3, and 4. Now it says my next one is 3. So with this one, I'm going to break them into 3 pieces. So that's 1, 2 lines. So you're drawing it 1, 2, 1, 2, 2, 2. My denominator is 3 because I'm breaking it into 3 pieces. All this talk about candy bars. I need a candy bar stat. All right, now we jump. 1, 2, 3. 3/3 is equal to 1, 5, 6, 7, 8, 9, 10. I need to like nail this board down. So I did exactly what they asked, right? 2 fractions equivalent to 4 using the denominators of 1 and 3. So my answer would be, I'm going to look over here because it was talking about 4. It wants to know what 4 is. So 4 is equivalent to 4 over 1, and it's also equivalent to 12 over 3. If I do 3 times 4, it equals 12. 12 divided by 4 is 3. 4 divided by 4 is 1. 1 times 4 is 4. Pretty cool how that all comes into play. So this will help with some of your automaticity with your math facts too. So I hope that makes sense. You might need to rewind that one and watch it again and again because it's confusing. But that's where you have to be little word detectives and find those clues where it talks about, write 2 fractions, 1 and 2, with equivalent to 4, and they have to have the denominators of 1 and 3. So just take it in baby steps. It's okay to start small. Again, if you have any questions or need anything from me, I'm always here for you. So just send me a message and I'll help you out. Bye, guys.